Okay, solving an absolute extreme. So we have this equation here. And this equation represents, we'll say it's an electrical fence putting out some type of amperage. And this is, the amperage is modeled by this equation here. And the question is asking us find out the maximum and minimum amperage between these times. Okay, time is measured in seconds. Okay, so T refers to seconds. And A is amperage. Well, the CAT is amperage. Okay, so we'll call CAT your amperage here. So it does have intervals. We know it has 0 and 5, so we're definitely going to have to figure out those 2 points because depending, those themselves might be the max and minimum amperages in this time. And the other options are when we have horizontal lines, tangent. So if we're trying to find the slope of a tangent to this curve, we need to derive this function. So when we derive this function, C prime t is equal to negative 3t squared plus 2t plus 21. Okay? So this is our derivative of our original function. We also got to find out when the slopes of these tangents are 0. So in other words, when C prime t, our tangent slopes are 0. So we set this equal to 0, negative 3t squared plus 2t plus 21. Now, in order to solve this, you've got to think back to factoring. And not just easy factoring, you got to think back to factoring when your a value here is a number other than 1. So I'm going to go over a style. I don't know if you guys know this one, but when we do factoring, what we do is first thing we do is actually we factor out. We always try to make the first term positive. Okay. So what I'm going to do is I can multiply the entire equation by a negative term if I like, just because I like positive first terms, which just gives me 0 again, 3t squared minus 2t minus 21. Okay. When I factor, I find the factors of my first term. Well, the only factors of 3t squared are 3t and 1t. So that makes it easy for me. I set it up into a column. Good, those are columns. Okay. Column. And then I find the factors of the last term, 21. Well, factors of 21, I have lots of options. 21 and 1 and 3 and 7. Not that many options I like. Okay. And I set these up in columns. What I'm then going to do is I'm going to multiply the first column by one of the second columns. The product of these is going to add up to our middle term, which is negative 2t. Okay. So, trial and error. 3t times 21 and 1 times 1, that gives me 1 and 63. No combination of that gives me negative 2. So that won't work. 3 times 1 and 1 times 21, that gives me 21 and 3t. No combination of that is going to work. So I know this column, 21 and 1, doesn't work. So I'm going to try the other column. 3t times 3 gives me 9t. 1 times 7 gives me 7t. Ah, okay. I can get a combination of this to work. Okay? So I'm going to draw those in permanent. 3 times 3 and 1 times 7. That gives me 9t and 7t. Now, one of these will need to be negative in order to get negative 2. Which of these will have to be negative when adding? The 9. Okay? Which means, recall, this was negative 21. One of these terms had to be negative. Well, because to get the 9 and multiplied by the 3, I make the 3 negative. Okay? So my factored form, I take the first 2 terms from the first column. So I put a 3t in and a 1t. And then, due to FOIL, whatever I multiplied by, so the 3t I multiplied by negative 3, the 3t and the negative 3 have to go in opposite columns. Okay, so I have negative 3 over here. And the 1 and the 7, well, the positive 7 goes over here. Okay? So here's my factor form. 0 is equal to 3t plus 7 times t minus 3. So then, I know that, or I'm going to set each of these brackets equal to 0 and find out my options for t. 0 is equal to 3t plus 7. 0 equals t minus 3. T is equal to 3 in this case. And this one we get negative 7 equals 3t. T equals a negative 7 over 3. Those are my options for t in terms of time. But remember, these are on intervals. Very, very important. I go to my intervals. My intervals have to be between 0 and 5. Only one of these falls between 0 and 5. This here does not fall between 0 and 5, so it's not an option for us. The only option is 3. So, my turning point is at 3. My initial and ending points are 0 and 5. So I have 0, 3, and 5. I need to find C at t for all of those values when t is equal to each of these. So we take our original equation. C at 0 is going to be negative, 0 cubed plus 0 squared plus 21 times 0. That's going to give us 0. We got that. 0, or C at 3 gives us negative 3 cubed plus 3 squared plus 21 times 3. 3 cubed gives us negative 27. Okay. 3 squared is 9. And 3 times 21 is 63. That's, what is that, 72 minus 27. Let's do this the easy way. 63 plus 9 minus 27. 45. Oh, that was nice. And C at 5. Negative 5 cubed plus 5 squared plus 21 times 5. Negative 125 plus 25 plus 105. Okay, that's going to give us, I think, 5. Yeah, that gives us just 5. So maximum and minimum values. Well, our maximum is 45 and our minimum is 0. Okay, so our minimum occurs at the starting point of t equals 0, and our maximum occurs when t is equal to our turning point at 3.